Welcome to tonight's forum, and thanks for taking some time out of your busy Tuesday evening to be here. Tonight's forum is co-hosted by the Milken Institute and KPCC. My name is Matt Horton, and I work in the Milken Institute's California Center. We're grateful to KPCC's president, Bill Davis, and to Melanie, Steve, John, Janice, Liz, and production events team for being outstanding partners in our ongoing public forum series here. This is our second forum addressing the drought and the needed enhancements to the state's water policies and infrastructure. You may know that the Milken Institute is a nonpartisan, nonprofit economic policy think tank. In the California Center, we help policymakers address issues concerning policy development related to the state's economy and promoting a vibrant long-term economic viability. The next Milken Institute forum is Tuesday the 27th. We will be welcoming award-winning journalist Julian Tett, the U.S. managing editor for the Financial Times, interviewed here by John C. Lee Brown, famed tech guru and one of the creators of Xerox PARC. They will discuss her new book, The Silo Effect, The Peril of Experience, and the Promise of Breaking Down Barriers. For today's panel, please tweet, text, and email your questions to the listed numbers and handles that will be on the side panels here. The addresses will be shown periodically, so you don't have to remember them. And make sure to include your name and your city. And moving forward, help me welcome tonight's moderator, KPCC Environment and Science Editor, Mr. Steve Gregory.
Thank you, Matt, and thank you all for coming. And thanks especially to our panel of experts for taking time out of their schedule this evening to join us. I'll introduce them in a second, but before I do that, I'd like to set the table for what we want to accomplish in the discussion tonight. As Matt mentioned, I'm the Environment and Science Editor at KPCC Public Radio. It is Pledge Week, by the way, so that phone number is 866-888-5722. Phones are waiting, standing by. Last month, we aired a special series of stories called The Future of Water. It looked at how California's relationship to water might change by the year 2040, given predictions that the state, on average, will be much hotter and much drier because of climate change, and also much more crowded because of population growth. So given those trends, this drought, this current 4-year drought, which has us very much in its grip, has made it clear that California's traditional relationship to water is no longer sustainable. So I think everyone is in agreement in this room and across the state that we as a society need to make changes. But what exactly those changes will look like is still unclear. So how, for instance, are we going to stretch existing water supplies? How are we going to secure new water supplies? And what will be the role of technology in all of this? And that's just the technological side of it. Of course, they're probably going to be needing some changes in policy, public policy, and probably just in conventional thinking on how any of us think and treat water. I mean, we pretty much take it for granted right now. We just turn on the tap and expect it to come out, and sure enough, it does. But I know that this drought has kind of given me pause every time I turn on the tap, and I'm sure many of you too. So we'll be unpacking all of this tonight, and joining us to unpack all of that. And panelists, actually, when I introduce you, please raise your hand so that the audience can keep us all straight. I'm Steve, by the way. So joining us in alphabetical order is Andrew Fallon. He's the program officer for the California Water Foundation. It's a think tank that works on policy initiatives to transform the way water is managed in California. And prior to joining the foundation, Andrew was executive director for the Water in the West program at Stanford University. Also with us tonight is Nick Hahn, who directs the Global Grand Challenges program for Singularity University. Right now, Nick is in the process of collecting submissions from all around the world for an innovation challenge looking for technological solutions to create new sources of water. And Nick told me tonight that they have around 1,000 submissions from around the world, people who are trying to come up with innovations to basically help the entire world, for that matter, have more reliable water sources. Actually, that competition closes on Friday, so if you want to get your submission in, you've got a couple more days. But the top 3 teams that can come up with technology to provide the most water will win the competition. Also with us is Lorcan O'Herlihy. He's the founder of Lorcan O'Herlihy Architects, a local firm, Santa Monica. Since 1990, the firm has worked to transform urban landscapes to be more than just a series of buildings, but also what Lorcan calls catalysts for change. And if you drive around Santa Monica, you will see his firm's work on almost every street corner. The firm designed the distinctive bus shelters for the Big Blue Bus. And those shelters are not only just shelters, but they're also solar power and stormwater collectors. So Lorcan's been thinking about sort of this dual use idea of structures for a long time. Also with us is David Pettijohn. He is the Director of Water Resources for the Los Angeles Department of Water and Power. And right now, most of the water that DWP supplies Angelenos comes from hundreds of miles away through a series of aqueducts, basically imported water, which is increasingly unreliable, as the recent snowpack measurement, or the snowpack measurement in April, will attest. So part of David's charge is to work to cut by half LA's reliance on imported water and switch to more local sources by 2024. So, and finally, rounding out the panel is Dr. Kelly Sanders. She is an assistant professor in the Sunny Astani Department of Civil and Environmental Engineering at USC. Among her areas of focus is something called urban metabolism, where she analyzes flows of energy, water, and wastewater in urban environments. So that's our distinguished panel, and so we'll start with the discussion. The first question goes to Nick. So Nick, since June, as I mentioned, your organization has been receiving submissions from around the world on ways to use technology to create new water sources. So without getting too specific, because we know you're still accepting submissions, what kinds of ideas are you seeing that have the potential to be a game changer when it comes to being more drought resilient?
Right. So at Singularity University, we work at the interface between what we call exponential technologies, a range of technologies that are doubling their capacity year in, year out, innovation, and solving humanity's grand challenges, water being one of those challenges. We issued an open challenge to innovators around the world to help come up with a solution for California's drought. And in particular, we narrowed that challenge to come up with ideas to create new sources of water. In other words, conservation was not part of the innovation challenge. And we've had a range of crazy submissions. I can't go into details in them, but this is everywhere from ideas on capturing water from the atmosphere and doing it more effectively, although scale, and doing that at scale is a big challenge, to new approaches to desalination that approach the energy, that address the energy limitations and also the environmental limitations and issues, such as putting barges out in the middle of the ocean and doing the desal out in the middle of the ocean so it doesn't have the environmental effects on the coastal marine resources. New membrane approaches, new membrane technologies. I don't know how much detail you want me to go into on this. The use of graphene as a membrane for reverse osmosis and forward osmosis is used to reduce the energy demands, and many other exciting innovations that are coming. Our job now is to sift through those. It was an open innovation to people around the world, and now we have to look. Some of them are really pushing the boundary of physics, so we have to make sure that they stay within the boundary of physics and their ideas are actually doable, and that's what our team of faculty and reviewers are doing right now. And the challenge is open until Friday. If any of you have ideas, please go to our website, Singularity University, and submit your idea.
Great, thanks, Nick. So Kelly, over to you. As I mentioned in your introduction, you specialize in what's called urban metabolism, and this is the idea that energy flows, water, wastewater streams, are all part of an organic whole of a city. So I was hoping that you could give us an example of a technology fix to help that urban metabolism function better in a drought, and in particular, I was hoping you could give us a technology fix that isn't getting as much attention as you think it should.
Yeah, well, just to explain this concept of urban metabolism a little bit, if you think of a natural ecosystem, it takes in sunlight, it takes in nutrients, and it produces energy through photosynthesis. And that system also reutilizes its waste. So a tree, for example, drops its leaves and it utilizes those resources by sucking up the nutrients again, which helps it grow. And so I apply that concept to a city. The city uses flows of energy, flows of water, flows of nutrients in various ways. And I think traditionally, we've kind of looked at these systems as siloed. So we look at the energy that goes into the city, or we'll look at the water. And I'm trying to take those technologies and really bring them together and think of them as a holistic system. If you take a shower, taking a shorter shower actually saves energy because you're saving the heat embedded in that water. The same thing, turning off your lights actually saves water because there's a lot of water embedded in the power that we utilize. So I look at those synergies. So, you know, if I'm being bold, I think that computing and teleconferencing and transportation, it's really gone from centralized to decentralized. And so I think you're going to see a lot of decentralization of the water system over time. You know, I think our homes and our environment is going to get better at capturing water. I think it's going to get better at capturing energy. So we have a lot of energy embedded in our sewage and our wastewater. Can we capture that in a device, such as a fuel cell, and utilize that energy for a useful purpose? Or can we capture the waste heat from some of our processes, from our air conditions, and use that in a useful way? So my work is really trying to figure out those synergies and find out what might be cost effective to leverage some of those synergistic conservation opportunities.
So Lorcan, it sounds like you know, one of the things that Kelly was talking about was this whole idea of sort of decentralized, you know, water, and I know that that's something that you've been working on in your own designs. You basically, your firm has been, you know, designing homes and structures that are more than just buildings, but they have a dual purpose. And maybe you could describe.
Well, we were asked to be part of an exhibition in downtown Los Angeles, the A+D Museum, to tackle the LA River, and we took the approach that the LA River is an ecological resource. We also recognized that the show was called Shelter, Rethinking How We Live by the year 2040. So we hybridized. We wanted both infrastructure and housing. We felt that the nature of housing should be performative. And we think that as opposed to convention of a stucco box house with nail-on windows, you can push architecture to where it starts to capture water. And so our strategy was to look at 5 or 6 interventions throughout the city, and primarily in Elysian Valley, Frogtown area, where how we can really tackle that idea. We don't capture much water, and I think Kelly was just mentioning that, but we think that there are ways of using housing and the actual roof of houses, walls, to actually play that role. So
how would that work? How would you use roofs and walls to capture water?
Right. I think right now what happens is the nature of housing and shelter is that the water hits the roof, it drops down to the street, and then it goes into the storm drain system. And that goes to the LA River and down to the ocean. So we can hack into that system of the storm drain system, capture it, recycling it, storing it, and redistributing the water. So there's ways that we can change that number in terms of 2 to 3 or 5% of water we capture and retain, and we can push that by virtue of using this issue of future needs of housing. This is coming, more people are coming to Los Angeles. Well, maybe there's a way to provide that opportunity through the nature of building structures, whether it's places of workplace or it's housing. And this, I think, is a critical issue to combining and hybridizing 2 structures, infrastructure and housing. They don't need to be separate. And this is something that can be done because, in a sense, you need it, you're building it, so why not rethink that convention?
So, David, David's with the DWP, an organization that basically supplies drinking water to 4 million people in Southern California, more than any water agency in California. And right now, as I mentioned, most of that water is from imported sources coming hundreds of miles away in aqueducts. But as DWP is on record saying that you want to cut those supplies by half and rely on more local sources. So I'm wondering, and pretty quickly by 2024. So so. I'm just less than 10 years. I'm just wondering what kind of technological advances is DWP going to need to reach that goal?
Well, you can imagine that's a pretty lofty goal, and this is a goal that the mayor has set for us through one of his executive directives, and we're working on essentially a three-pronged strategy to try to meet that goal in arguably a fairly short period of time. I like to refer to it as a capture, conserve, reuse strategy. So capture. So it's the idea that there's a lot of rain that falls. Traditionally, that has not been viewed as a water supply source. We have captured a lot of rainwater over the years in the city of Los Angeles. We've made a lot of investments in it, but we're planning, and our board has approved this, we're planning on doubling or tripling the amount of stormwater capture the city does in a typical year. So that's one strategy. That's your capture. Then conserve. The city of Los Angeles, believe it or not, is probably the premier water conservation city in the entire United States. And I don't say that lightly. I mean, the gallons per capita per person per day in the city of Los Angeles now is 109 gallons per person per day. Now that sounds like a lot, but that's including all the industry that occurs in the city of Los Angeles, all the commercial, industrial, institutional uses. It's all our water loss, evaporative losses, leakage, fire flows. It's an all-in number, so it's a pretty low number. But to put this in perspective, when I first started at DWP, and that was a couple of years ago, the typical person in the city of LA, that all-in number was 189 gallons per person per day, and we're all the way down to 109. So we've really trimmed it a lot. Essentially, conservation is the foundational effort in Los Angeles to meet this goal. So we're planning on ramping up our conservation efforts. If you're in the city of LA, we're one of the only cities in Southern California that still offer a rebate to take your lawn out. We'll give you $1.75 to take your lawn out. We have tremendous incentives for all indoor plumbing fixtures. So that's kind of the conserve effort. And then the reuse effort. Water recycling is something we've tried to do for a long time. We have a lot of purple pipe out there. That's essentially water that goes through a wastewater treatment plant, is treated tertiary level, and then it goes out and sold to customers to use as irrigation water. We want to ramp that up substantially, but we also have plans to take advanced treated recycled water and recharge our groundwater basin with it so that it can be pumped and served to customers for potable uses. So those three strategies are really the primary way we plan on meeting this grand challenge, the capture, conserve, reuse strategy.
So David, you mentioned that the city is hoping to double, if not triple, the amount of stormwater it captures. How do you do that?
Well, we spent 2 years looking at this and trying to think about how could we do it. So there's really it's kind of a two-pronged answer. Stormwater capture, you can do it on a grand scale, and we do a lot of that. We call it centralized stormwater capture. We partner with the LA County Flood Control District. They have several dams up in the hillsides. Those dams feed large spreading basins which recharge the groundwater basins. So you're making improvements in those facilities, either mucking out behind the dams or making improvements at the dams so they can capture more water. You're making improvements in those spreading basins, mostly out in our San Fernando Valley, to increase the infiltration rates that you can get that stormwater into the ground. So that's the large capture, centralized projects, big projects. But what we hadn't really focused on that much in the past, and we really are going to be ramping up, is our distributed strategies. And these get down to some of the strategies that are more neighborhood level and even residential level. So at the neighborhood level, there are things that you can do. In the San Fernando Valley, we're very fortunate because there aren't a whole lot of storm drains in the neighborhood areas. So a lot of the runoff just hits the streets and stays there. So if you can interrupt that water before it gets into the main storm drain systems that are in the main streets out in the valley, you can get it into the ground. And that's what we're doing. We're building facilities that interrupt that storm flow before it gets into the storm drain system and puts it into underground infiltration galleries. So we've done a lot of these projects out in the San Fernando Valley. So that's kind of a neighborhood level projects that you can do, dry wells, cisterns, things that are in the parkways. And then there's a residential level project. So right now we will offer you $100 to put per rain barrel, and you can put up to 4 rain barrels in your property, capture. So we give about $400 to do that. We'll pay you to take out your lawn, and that we have incentives to help you learn how to grade your property to keep more of that water on your property. We're working on cistern rebates. We're going to try to get one of those out there so people can actually have a cistern on a $1 per gallon captured basis. But these are the residential level projects. So when you start thinking about stormwater capture, it's the large centralized projects, the neighborhood level projects, and then the residential level projects. And we're going to be investing in all 3 of those.
Thank you. So Andrew, we've heard a lot about technology, but I was hoping that I could throw a question to you about sort of innovation in the policy arena, because technology doesn't happen in a vacuum oftentimes. So what sort of changes do we need to see in public policy to maximize some of the technologies that the other panelists have been talking about?
Well, you often think about technology as being a great savior and an opportunity for change, but to create the kind of environment that's necessary for innovation, many of the innovations that were described here, we really do have to go back to the policy arena. And so several examples that the panelists have already shared so far either are confronted with constraints because of existing policy, or can be better facilitated through incentives. And we've seen already what the government can do to motivate change using a stick. The governor's requirement this year that we all reduce by a minimum of 25% of our water consumption has been a large success, but given some opportunity for incentives and for other kinds of changes, I think we can do a whole lot more. One of the challenges I think that California is confronted with is that we tend to be very siloed, and I think Kelly alluded to this before, in how water is managed. So water that is used and disposed of is administered by one agency, and then water is delivered by another agency, and then the landscape is managed by yet another agency. And so we heard about landscape, we heard about supply, and we've heard about treatment. Well, we've got to actually start to align the policies and the incentives and the agencies themselves that are all involved in this array of things that ultimately lead to water sustainability. We've got to get them all aligned and working more together. We've, at the California Water Foundation, we've laid out some recommendations and plans at the state level that you can find on our website at californiawaterfoundation.org. I guess one last thing that I'll mention is that the public is really hungry for this right now, and I think that there is a real opportunity to affect change in the public policy arena, unlike we've ever seen before. We did some polling recently that showed that 86% of Californians view the drought as either very or extremely serious, and our pollsters told us they had never seen numbers like that ever on any subject. With possibly the exception of the energy crisis over a decade ago. So we have an opportunity to actually affect public policy change in an area that is typically very static, and it's just a matter of rolling up our sleeves and doing it.
You mentioned an interesting thing about incentives. Right now, as we all know, there's an enormous push for more housing. There are more people coming here, and the idea that Los Angeles is primarily a privatized city, and you have public infrastructure and you have private housing. If there's some way to break that barrier between private and public and start to weave the two together by virtue of possibility of incentives for developers or who are producing these buildings, but they're not really seeing these buildings other than shelter. They're not seeing it as opportunities to actually contribute to the community, contribute to critical issues. And I think that since we're building these, that's an opportunity, I think, to really start to tackle that issue. It can be done. We worked on projects where we have put public parks on private land, and that was a very complex situation, but it can be done. And that was a very important project. It was a pocket park in a project I did in West Hollywood. And that, when it started out, there was a conclusion that it couldn't happen. But by the city working with the developer and the whole team, the architects and everyone else, and the landscape architects, were able to produce this public park and private land. So you can argue the case that you could tackle water in the same way, that perhaps these buildings and houses could be able to utilize it to replenish the water table by capturing it.
Well, we do a little of that in Los Angeles. We have a low-impact development ordinance, and so we do require anybody who does a new development in the city that's more than 500 square feet to do stormwater capture and keep that first flush of water on their property and reuse it. So you're right. I mean, if you can get these ordinances in place inside the cities that mandate some of this, especially for new construction, it's very easy to do.
Right.
Where it becomes difficult and the policy challenge becomes, what do you do with all the existing infrastructure? What do you do with all the existing development? That's where it becomes more challenging, because you can't just mandate that people retrofit their properties. So that's where you get into trying to incentivize people to do the right thing on a property that's already been developed.
I think it can happen. It's just a question of looking at the structures we're building, and those are opportunities. Roofs, critical. Right now they're used for solar, but there is an opportunity to really recycle that water that comes on those roofs, put them into cisterns, being able to filter in system, replenish the water table, and it can really work. And I'm convinced that that is perhaps where we're going, rather than piping from other areas, but actually tackle it from a bottom-up strategy within the city.
You know, it's interesting. I mean, we've been hearing a lot about the LA River and, revitalizing the LA River and sort of rethinking the LA River, which right now it's a giant storm drain, basically. We try to funnel as much water to it as possible, as quickly as possible, and then it goes right down to the Long Beach Harbor. But the more, and, there's been a lot of discussion over the past several months about restoring the river to a more natural state. And, Frank Geary's involved with some preliminary conversations about reimagining the river. But I'm wondering if there's a conflict with this whole idea that we want to capture and store more rainwater. In other words, right now, the predominant flow of the LA River is treated wastewater. And if we are diverting more of that wastewater and natural stormwater into cisterns or into spreading grounds, into replenishing aquifers, can we do both? Can we conserve that water and still have the LA River playground that everyone's talking about? Anybody want to take that one?
Well, I'll make a stab at it. I mean, the environmental document for the LA River restoration is out now. If you want to take a look at it, you can catch it on the website. Just Google search it. It's out. There is a challenge. I mean, there are competing interests, and there are always going to be competing interests in society for environmental restoration versus infrastructure needs and needs for additional water supplies. And you've got to balance those needs. So that thinking is currently going on. So, but you're right. I mean, there is a certain fixed amount of water that's available through some of the wastewater treatment plants that currently feed the LA River. There's a certain fixed amount of dry weather stream flows that gets into the river from people who essentially are overwatering, and it flows, gets into the river. So there's even in dry weather, there's flow in the LA River, and you can go down and you can see that flow. So the question is, if you're going to use some of the water supply that's currently hitting the LA River to recharge your groundwater basin or to find other uses for it, what are going to be the impacts on the flows in the river, and how do you balance those needs? And it's not an easy issue to deal with. But one thing you mentioned that I think Friends of the LA River would take you to task for calling the LA River more of a storm drain than a river. So I'm going to correct you on that one.
I appreciate that correction, but I would also say that a year-round flow in the LA River is not necessarily a natural state for that river. But anyway, So Kelly, one of the things actually, I'm sorry. One of the things that we only mentioned in passing was desalination. And, I know that obviously we have the Poseidon desalination plant opening in Carlsbad next month. There are also plans the company that's opening that plant is also trying to get a similar plant open in Huntington Beach. And, you know, a lot of folks are looking at desal as this sort of great, you know, panacea. I mean, we've got a near limitless supply of water, you know, right on our western edge. You know, let's use it. But there are a lot of folks there are a lot of folks saying that you know, desal isn't all that it's cracked up to be. I know that you have some thoughts on that. What's the knock on desal?
Yeah, so I mean, the important point here, I get this all the time from my students, is California isn't actually water scarce, it's freshwater scarce. And so that's the challenge. And my work at USC looks a lot at this concept of the energy-water nexus. Water requires a lot of energy, and energy requires a lot of water. And desalination is the perfect example. You know, yes, you have the ocean, and yes, you could potentially desalinate it, but taking salt out of water is not trivial. I mean, the analogy is boiling water on your stove. Think of how long it would take to evaporate that water to remove the water from the salt. We have more efficient processes available to us, but at its core, it's very, very energy intensive, which is expensive, and it kind of conflicts with some of our energy goals, right? The other thing about desalination is you create a very high concentrated brine. So all of that salt has to go somewhere. And with seawater desalination, you typically only recover half of the water that goes into the plant because that's all that's economical to recover. You know, basically you're using membranes to, with very high pressure to remove the salt from the water. So you have a lot of discharge. For every 2 gallons you put in, you have 1 gallon of waste. And that's not trivial to get rid of. In the Middle East, they're doing tons of desalination, and they just put the discharge back into the Gulf. They've actually increased the salinity of the Gulf, which creates this positive feedback loop where they're kind of kicking themselves because it's more saline, so it requires more energy and has more environmental impact. So you create this positive feedback loop. Here in the United States, and particularly in California, we're really concerned about the environmental impacts. So we're concerned about the water that comes in. How do we suck that water out of the ocean without creating an impact? Does that happen through a subsurface filtration system? As you can imagine, that's not trivial. Or do you just stick a pipe in the ocean and suck things out? But how do you, you know, get barnacles not to attach to those pipelines? So it's not a trivial issue. So yes, desalination could be looked at as our silver bullet, but I would challenge anyone that says that. The energy intensity of any sort of water treatment is dictated by the differential between the beginning quality of your water and the end quality of your water. So to me, wastewater reclamation makes much more sense because you have treated wastewater effluent, which is pretty clean to begin with, and so you just need a little bit more energy to make it drinkable. We have to get our head wrapped around what that looks like, but I think that's the bigger opportunity than desal. And I think we have to be careful as we do develop these desalination plants that we don't use it as an excuse to grow unsustainably. So, you know, I think we have to make behavioral changes in addition to the technological changes.
So I'm sorry, what do you mean by that? You use desal as an excuse to grow unsustainably?
Well, you know, currently our baseline is in any given year, we import up to 90% of our water. And we can get better about capturing water locally, but we have a bigger population here than we have local water resources. So something has to come in. And so you could say, yes, we could desalinate the ocean to support more growth, but I think at some point you bump up against the limit of, you know, what quote unquote is sustainable when you think about the environmental impacts and the ecosystem impacts and the energy impacts.
Yeah.
Can I riff off that?
Andrew, and then Nick, please.
Sure. Just to build off of that a little bit, you know, I think one way to think about desalination is that it's as compared to what, and so you really do have to look at what are your alternative supplies, and you're either looking at developing new water, so recycling or stormwater capture may be an example of that, both of which are typically cheaper than desalination. Efficiency considerably cheaper than desalination, and then markets and trading are sort of a third category of opportunity when it comes to water supply, and that's an area that I think that we've not done as well with in this state as we can. There are certain entities that actively engage in trading water throughout the state, but we are constrained in those activities by either a lack of infrastructure or sort of arcane laws that don't permit it as effectively and efficiently as it can. Now, we do have to protect environmental interests, and we have to protect third parties, so particularly low-income communities and others when we get into things like markets and trading. But there's a wealth of water throughout the state. It's just a matter of creating an environment in which we can exchange it more efficiently and effectively, and I think there's opportunity to do that.
Nick?
Just to add, while on one hand I completely agree with the issues that you pointed out with regards to desalination, the environmental issues, the energy point, et cetera, that's using today's technology. So for innovators out there, for long-term investors, the challenge is to look where this technology is going. What's the research in materials science with graphene as a membrane that will make the price point, the energy point for reverse or forward osmosis much cheaper, with energy production itself becoming much cheaper in the future, and what opportunities that has to unleash this limitless water resource that we have. It's what we call at Singularity University the abundance mindset, looking where a resource is actually not scarce, but looking for a clever, innovative opportunity to get that resource, and looking at and anticipating where that's going in the future. I agree with the limitations right now, but that shouldn't shut off R&D. It shouldn't shut off innovators who are interested in exploring that. And then I want to put another thing on the table here with regards to salt water, seawater. Right now, we don't grow crops with salt water, but research is being done to bioengineer crops that can be grown with salt water. So now, and we haven't, so far we've been talking about California's urban water issues. There's a whole big discussion, of course, on the 80% of the water that's used in California for agriculture. And I hope we're going to talk about that.
Absolutely.
But just to point out that incredible body of water that we have off of our coast could also be used to irrigate our crops with bioengineering that could use the salty water. This is early stage research, of course, lots of issues involved there, but just to put that on the table there too, we're not limited by using fresh water for our crop production either.
So Nick, you brought up agricultural water use. There is a statistic that's bandied about often in water conversations that basically the ag industry uses about 80% of the water used by people in the state, whereas cities use the other 20%. So clearly there would seem to be some room in agriculture for a rethinking of how water is used. I know that several farmers, or many farmers, are switching over to drip irrigation, which some people have described as actually spoon feeding plants. And now, and Andrew, you might be able to talk about this. My understanding is that digital technology is now as much a part of drip irrigation as plastic tubing and PVC piping.
Yeah, it's extraordinary what's going on in agriculture right now. There's huge conversion to drip irrigation. Sensors that are placed through the soil to measure and monitor moisture levels to be able to then apply water as needed. I think they're using drone technology now to monitor crops from the sky so that they can tell what needs fertilizer or water application when. So really incredible innovations taking place. Certainly challenges with those things as well. And again, I think it's important to keep in mind that when water's saved in the agricultural sector, it doesn't necessarily then become freed up for somebody else to use. Typically, it gets used for another acre of whatever it is you were planting. So there again, I think comes through this issue that I'm becoming a broken record about, which is that the policy space is a really important complement to these technological innovations, because we need to make conscious decisions about how it is that we are going to manage what is a limited resource with a growing population.
It's interesting, this issue about of the farming condition, and you combine that with the idea of the city, that 85% of the population will be living in cities. Right now, they're really challenged, certainly within Los Angeles in the drought. And when you're in downtown Los Angeles, there's a heat that's absorbed by the materials, not only the structures, but use sidewalks and streets. So when you're there, there's real issues, and it is really addressing the issue of the drought. So there are ways to rethink those materials. And those materials, if they were rethought, would be much more interesting as opposed to absorbing the heat, find ways to kind of dissipate the heat. So when you're in the cities, all of us walk throughout the city when on a drought, and it's a very, very unpleasant experience. But there are ways that you can push in a broader way, tackling materials of not only structures, but also sidewalks and streets, all those. And it can be very helpful because you can get porous and permeable asphalt. You can find materials where the water is absorbed and replenished in terms into the water table below. It doesn't have to be utilized just to redirect the water to the storm drain system. There's ways of really addressing that issue. You mentioned also the LA River. I do think that there's a combination. There's a lot of studies looking at the river primarily as a recreational component, but also the idea of hydrology, which is Frank Geary's looking at, and that's essentially what we were looking at, a portion of that as well with our proposals, is how do you find both of those work? It's not simply just a place to go to, but it's also an opportunity, because rivers mean that there's aquifers. It means that there's tributaries. There's all kinds of elements within the river kind of framework, so to speak, where you can start to address those issues. So it's really an interesting challenge that we have right now in Los Angeles.
David and then Kelly.
Yeah, there's a real policy issue here between urban Southern California and urban areas in general and agriculture. And the truth is that you've got a very small percentage of the population that control the agriculture, but they control about 80% of the water in the state of California. So you've got this small population that controls most of the water. Then you have this huge population that has 20% to live on. So they've got the water, but we've got something they don't have, money. So the way you do it is we don't need the water from the farmers during normal and wet years. But during drought years and situations like we're in now, we desperately need the water. So what has been happening, and it's been happening in California for a number of years now, and it needs to expand to become more pervasive throughout the state, is dry year water transfers. So what you do is you pay the farmer to fallow his land during the dry years and transfer the water to you. So you form an agreement where you're paying him a small amount of money every year so that during the dry years you can call on that water, he'll fallow his fields, and he'll transfer the water to you. So I know that oftentimes policy thinkers think, well, there's this breachable gap between ag and urban. But that's really not the case. There are ways to creatively bridge these gaps with policies like this that facilitate these kind of agreements, and we just need to do more of it.
Kelly.
So one of the things that I think is really important to address, and sort of the elephant in the room that not a lot of people like to talk about, is the issue of water rights and how that translates into the agricultural water sector. Right now we have a system where it's first in line and first in time. And so while you see a lot of great stories about how we've gotten more efficient in the agricultural sector, you still have senior water rights holders that have absolutely no economic incentive to conserve. And so what you saw last year when the State Water Project, for the first time in history, didn't deliver water to farmers is that the junior water rights got cut off while the senior water rights were still able to flood their alfalfa. And what happened during that transition is the junior water rights had to either fallow their land or they had to figure out something else. And what that something else was groundwater pumping. And so the Central Valley of California has been overpumped, and we are losing water at an unprecedented rate, very unsustainable rate. But what's happened is because of the energy impacts and the cost impact of getting that groundwater out of the ground, we saw this huge transition to more lucrative crops. The farmers that bought the groundwater pumps now had to get more economically productive crops. That was generally almond trees or some type of trees that can't be fallowed from year to year. So I think there's a tremendous opportunity to look to water markets for transfers between urban and ag or energy and ag. But at the same time, some unintended consequences of this water right system that we have is the people that could fallow, that are irrigating and flooding the very cheap crops, are not the ones that need the water. And the junior water rights holders are starting to transition to these crops that can't be turned over from year to year or can't be killed one year and come back another year. So some really interesting things have happened during this drought that complicate and confound the agricultural water management issue. And water rights are the elephant in the room. The state is starting to address water rights and starting to address the senior water rights holders. And I don't know if they have a legal ground to stand on. They own the water rights. So litigation is going to be crazy.
So Andrew, I see you've got your hand raised, and I will turn the floor over to you in just a second. I just wanted to just kind of put a little spin on the ball before you hit it, because I'm hoping that you might address two things that we've talked about over the past couple of minutes, and it's this idea of that there's sort of an inherent contradiction in conservation and water efficiency, and that is the more you conserve, the more incentive you have to use more, or to use what Kelly said, basically, folks who don't have any have to pump groundwater, and therefore they've got to plant, year-round high-yield crops to sort of break even, and so it's this sort of, this negative feedback loop, basically. So what do we do about this contradiction of efficiency, where the more we conserve, the more incentive we have to use the water we saved?
Well, I think on that issue, there's a difference between the way we use water more efficiently in the urban environment and the way that we use water more efficiently in the agricultural environment. And in the agricultural environment, you save water, and currently there are very few incentives to actually put that water to some other use. You basically, you basically can either put that water, you can sometimes sell that water, sometimes you can trade that water. That could and should be made more easy. But then there's also this problem of putting water to yet another crop. I think we can actually take public monies and even private monies that can actually capture that water, take that water that's saved, or even pay farmers to be more efficient. And in Australia, they did this to great effect, where big investments were made by the government and by water agencies in the urban sector to help farmers be more efficient. And in turn, they committed that water, that saved water, a percentage of that, some of it went back to the environment, some of it went to the city. So I think that there's plenty of precedents and mechanisms by which you can actually get the most out of that from a broader societal perspective as opposed to an individual profit perspective. The comment I wanted to make on what Kelly was bringing up is I think this issue of groundwater, especially in the agricultural sector and in the Central Valley right now, the bright light here is that last year the state passed legislation to regulate groundwater for the first time in 100 years. This is something that people had tried and failed for a long, long time. And finally, we have a framework and a structure in place that actually sort of plugs this, we describe it as plugging the leaky bucket. Everybody would kind of go to the groundwater well whenever the surface water was cut off and pretended like nothing was going on, that there wasn't a drought taking place. Well, no longer is that going to be possible. And what that is doing is actually spawning innovation. That policy change has got people out looking at technologies for sensors and sensing and how to monitor and measure groundwater basins in tremendous ways. Advances in agriculture and great innovations are taking place there. Great innovations are taking place in just the whole business of how do you get people to yes. How do you structure a negotiation? How do you reach agreements in these complex systems? And then, of course, we're going to have more innovations in efficiency and in transfers.
So speaking of innovation, and David, I was hoping to take a look at the example of this city. I'm just wondering, are we likely to see any innovations in price signal to help folks get the message that they need to conserve? I mean, I think if you were paying more for water, you'd have less incentive to use it, I guess. Are we likely to see a tiered or an increase in tiered pricing?
It's a very good question. Those of you who are not aware, there was a San Juan Capistrano legal case which essentially said that San Juan Capistrano couldn't set the rates the way they set them, and they essentially had penalty rates in there. So if you were overusing water, you got penalized, and that was in their rate structure. But the problem was they didn't have a cost of service nexus. So what the court said was, you can't just charge somebody a price for water because you want to try to control the amount of water they use, unless you can say that the amount of money we're charging them has a direct linkage to what it takes us to bring that water to them. So now all of us in the water business are scrambling to make sure that if we make changes to our water rate system, that there's a direct linkage between what we're actually charging in each tier of our water rates and what it actually costs us to produce that water in that tier. So what LADWP is currently doing, we have a two-tier rate structure right now, and the unfortunate truth is that the differential between those two tiers isn't even $1. So that, it's $1 per 100 cubic feet isn't very much. So there's not much of an incentive not to go into the higher tier. What we want to do and what we're going to do is we're going to take that two-tier structure and morph it into a four-tier structure. So we've been working with the lawyers very carefully. We've got a very good cost of service nexus between the four tiers and what it actually costs us to produce various water and what it costs us to purchase wholesale water on the market. The way we're structuring it is that first tier is going to cover someone's lifeline needs inside their home. So nobody's going to, that's going to be a low rate. People will have access to water inside their home. The second tier will cover a home that wants to have a California-friendly landscape. So it'll give you enough water for indoor use and to have a California-friendly landscape. The third tier will be a tier that covers non-California-friendly landscape. So if you want to have an outdoor traditional landscape with marathon lawn and a lot of plants and things that are not California-friendly, you're going to be into the third tier. And the fourth tier is going to be an excessive use tier, and that's going to be tied to our highest cost of water. And some of the more expensive water we produce is recycled water that we have to advance treat that water to serve it to our customers. So that's what we're going to do. And we do anticipate that that restructuring of our rates will really help us meet some of these goals to reduce water use citywide. So that's what we're going to be doing.
So David, how do you handle the outliers? And granted, they are the outliers, but they're the folks for whom price signals have no impact. And of course, there was the big story for the past couple of weeks of the unknown Bel Air resident who's using an obscene amount of water. And I'm just, how do you, and clearly that person, since they live in Bel Air, they probably have enough money to pay the highest tier. How do you change the water habits of that person?
Yeah, we have a lot of people in the city of LA who are fairly wealthy, and they have large properties. And we do have water use ordinances on the books that prohibit certain types of uses. But when somebody's got a 30-foot wall around their property, it's not easy for our water cops to drive by and see what's going on. So what we're doing, all of our highest water use customers get a customized water use report. And this is a pilot study that we started. We used 20,000 customers, included some of our very high water use customers. We're going to go to a larger scale of that program to 60,000 customers. They'll get customized water use reports that really show you how you're doing compared to your neighbors, what you should be using on your property compared to what you are using, and kind of grade you on that. So that's happening. The other thing that we're going to be doing is AMI. So we're going to be essentially taking smart water meters and putting them on these people's homes so we can track their water use. So when the city ordinance says you can only water 3 days a week, odd even, for 8 minutes a station, not between the hours of 9, after the 9 o'clock and not before 4 o'clock. If we see that their water use pattern violates that ordinance, then we're going to be able to go in and make changes to their water uses. So there are things that you can do. You can fine them, of course, but people who are wealthy sometimes don't respond to that. But you can put flow restrictors, and there are other things that you can do to make sure that people obey the city ordinances. But just because somebody uses a lot of water doesn't necessarily mean that they're violating the city ordinance. If you have a 30-acre property and you're irrigating that property properly during the hours that you're allowed to irrigate it, it's not necessarily that you're a water waster. But we do suspect that there are some very high-end water users that are wasting water, and we're going to be going after those folks.
I wanted to turn actually back to a rural water issue, not necessarily agricultural, but it was something that Kelly, you and I were talking about before the panel discussion, and it was this whole idea of, of potential water sources that are unexpected potential water sources. And one of the ones that you talked about was basically wastewater from the oil and gas industry in places like Kern County. And I'm just wondering, how in the world would you begin to start repurposing that water for other purposes?
Yeah, so my research group tries to look at a lot of unexpected places where we might be able to utilize water that we consider waste at this point and put it somewhere else. So a lot of my work looks at the water use in the oil and gas sector. And the oil and gas sector produces about 130 billion gallons of water. So, a lot of the rhetoric regarding fracturing talks about the water that you inject, but a lot of it doesn't talk about the water that you produce. So in California, and I won't go into the big details because we're on a water panel, but for fracturing, you're actually fracturing vertically. So you don't use as much water as a lot of other places in the United States. And you also are fracking at much shallower depths. So your radioactive elements, for example, aren't really being produced like they would in the Bakken Shale or in shales in Texas, for example. So what we're looking at is looking at the water that's produced from these oil and gas jobs and saying, could they be used for some synergistic usage? Could it be used in ag? Or could it be used for an even higher purpose? And there's counties in California where people have actually run out of water. So they have no drinking water. They are 100% reliant on bottled water. And when bottled water becomes your cost point that you're comparing against, you can do a lot of things. And so it is possible to get anything out of water with the right amount of money. We have the technology. So what my group's looking at is what are the dynamics of what those transfers would look like if we have 130 billion gallons to play with rather than injecting them back into the ground, which is what we do now. Could we utilize that and pipe it somewhere else? Right now we're seeing if there are synergistic opportunities between energy and commercial and residential in some of the rural counties that have run out of water. But we might also look at ag, although the scales have to be correct. 130 billion gallons sounds like a lot, but when you talk about ag, it's much, much more. So we're looking at some of those kind of unconventional opportunities. So when my students are done with the analysis, I'll get back to everybody. Stay tuned.
Thank you for that. We have been receiving a number of questions from the audience, and we are going to open the floor, so to speak, electronically, since you guys have been texting and tweeting your questions. So the first question from the audience is, what are the most promising emerging technological solutions in the pipeline? So what's sort of on the cusp, sort of in the beta development stage right now that's getting ready to explode and be a game changer?
He alluded already to this notion. Peter Gleck from the Pacific Institute likes to coined the term the smart water grid. We talk about a smart energy grid. Well, a smart water grid would be a water grid that's entirely networked and censored, so that we know. So whether it's for its municipality, we know when there's a leak immediately, and a remediation effort can be done, and we know where that is. Or if it's for agriculture, we know how much water to give a plant given its water requirements, its soil moisture, and it's an integrated system, as you say, with drones and with sensors and drip irrigation, very specific. So a smart water grid is our future of water, and that means any range of technologies involved there. Artificial intelligence will underpin that, given the amount of data and data sources, that the processing of that. Sensors and networking and computing power will underpin that as well, and integrated systems like drone technology will also underpin that.
Yeah, one of the things that kind of related to that gets me excited, and it's particularly relevant given the time of year and the forecast that we're all hearing about in the news with El Nino. Here we are talking about drought and this crisis, and suddenly we're going to be confronted with the exact opposite crisis of flooding, which are really flip sides of the same coin. And if we can start to look at how we utilize our infrastructure and manage our infrastructure to address sort of both problems alternately, using the same set of solutions, I think that those are great opportunities. And so just changing the way we use our dams, which we leave, ultimately we want to leave empty for purposes of catching a flood, but we want to keep full for purposes of maintaining a water supply. Well, if we can connect better to better weather predictions and storm predictions, we can operate those much better. If we can also connect those to the water demand downstream, and we can also connect that to more of a marketplace, you get more of an integrated system as well. So these are innovations that I think are perfectly within our means to deploy soon.
David?
One thing that I don't think it makes a lot of sense, and you probably all would agree with me, we import water from hundreds of miles away, we use it one time, and we dump it in the Pacific Ocean. So that's been going on ever since Southern California came into being. So what are you going to do to change that dynamic? Because there are hundreds of millions of gallons a day that just is flowing out into the ocean. Now, to recycle all that water is going to take a fairly mammoth effort, but you have two large wastewater treatment plants in Southern California. It's the Carson Regional Wastewater Treatment Plant that's run by the County Sanitation District, and there's the Hyperion Wastewater Treatment Plant that's run by the City of LA, but it contracts with over 15 different cities, so it's really a regional plant itself. Those two plants, there's over 400 million gallons a day that flow out into the ocean through those two plants after the water's been treated. So it's fairly good quality water that's going right into the ocean. So what the region has done is decided that for the first time in history, we're going to take a look at maybe trying to make those two wastewater treatment facilities a fourth aqueduct. So you have the LA Aqueduct, you have the Colorado River Aqueduct, you have the California Aqueduct. And now if this gets up and running, you would have essentially a fourth aqueduct that would be a regional resource to serve all of Southern California. And when I say all of Southern California, I mean the 6-county area from Ventura to the Mexican border. So what it's going to take is it's going to take a regional partnership, and that regional partnership already exists. It's called the Metropolitan Water District of Southern California. It's got 26 member agencies, cities, and wholesale water agencies They're going to band together to do a pilot demonstration project. And that pilot demonstration project is going to be located down at the Carson plant to take a look at this technology and see what it would take to make that wastewater a regional resource. If the pilot demonstration project goes well, they'll upsize it to a first phase, and then there'll be a second and a third phase with an ultimate vision of fully utilizing all the wastewater that flows through both the Carson plant and the Hyperion plant, and using that as a resource to recharge regional groundwater basins so that we would have another real source of water. And it would be much...
Throw a curve. Sorry.
Sure, go ahead.
Go ahead. They did say we can interrupt a little bit. So
Go ahead, interrupt me. I'm happy with that.
Could you add to that equation of public infrastructure to look at the private infrastructure in terms of, and let them get involved as well? Because I'm still convinced that there's such a separation between the infrastructure that exists and also an enormous wealth of other components, which is communities that can actually play a big role if it was done individually or collectively at communities. So I'm still challenged by these larger gestures, and there are actually resources, and this is the issue of incentives. Could one argue the case that you have all these components that you mentioned, but also put incentive into for the communities to actually get involved with it? And that is this public-private dilemma, because the nature of what you're talking about are public infrastructure. And how can one actually fold that into, and there's large communities here that could be involved. And it's just something that I know that in the bigger picture is every one of the cities, whether it's Santa Monica, West Hollywood, or any other cities in Los Angeles, people are fearful of tremendous development right now. There's more people coming. Does more people create more stress? And right now we're in a drought, and we have a very volatile environment where we have, an El Nino coming. Are we actually in a place to capture all that water, or what can we do individually to help to kind of address that issue?
Sure, and I completely agree with you. I mean, this large regional solution is just one small piece of what the needs of the region are going to be between now and 2040. I mean, between now and 2040, there's going to be a need for 350 to 400 million acre-feet of water that is above and beyond what we currently have. Now, to put that in some perspective, that's about an additional 10% of all the water that's used in Southern California in a typical year have to be generated. So one solution isn't going to solve it. And I agree, you need to have these large regional solutions have their place, but you need to also have the smaller, more distributed neighborhood level, residential level programs as well. And the way we do those type of programs is we offer incentives to people to do exactly what you're talking about, do on-property stormwater capture. In the city of LA, there's an ordinance that allows you to do a gray water system without pulling a permit on your property. There's a lot of things that residential customers can do in the area of conserving water and using less. We offer a lot of incentives for you to change out your washing machines, your dishwashers, your toilets. We offer incentives for commercial urinals and toilets. So we give away free aerators. We give away free shower heads. So there's a lot of things out there that you can do at the distributed level.
I'm convinced that Metro owns the land in terms of the light rail. Those properties have been sold, and developers are going in there and building. And if there was some structure or strategy in place that if they were to purchase that land in return to build, they would need to provide all these incentives to actually capture water.
Well, just one last comment here. In the city of LA, you do have to comply with the low impact development ordinances. Right. So inside our city, you are required to do that.
Yeah, it doesn't actually hack into the system and save it. It tends to, the low impact from our understanding is it just drops the water, and you do break it. It does go down to the groundwater, the water table. But it's interesting. There's other levels or layers that one could add into it where you're capturing it and recycling it. And that's the interesting thing, because we deal with that with all our projects, what you're discussing. I think there are ways to really challenge that.
Well, getting back to wastewater recycling for just a quick second, one of our audience members, Todd from Hermosa Beach, poses the question. So how do you deal with particularly when we talk about wastewater recycling, how do you deal with the public perception over issues like toilet to tap, basically? I guess it's a direct potable use of treated wastewater. How do you get past what people call the yuck factor?
So I can take that one. I love the yuck factor. This is what I do in my free time. I think about wastewater treatment. There's a few conundrums that right now faces wastewater reclamation. So we do recycle treated wastewater effluent now, but we are only able to use it in indirect potable reuse. So what that means is we can basically desalinate it. It's pretty much cleaner than the water that you get to your houses, and we can put it down into a groundwater aquifer. Well, that's great because it protects the groundwater aquifer from seawater intrusion. It provides storage. You have no evaporation. So that's a really great system. You can also take that water and you can give it to industrial facilities like the Chevron refining facility. But the problem is you are restricted in terms of mixing that with any potable stream. So that the problem with that system is for you or I to get access to that recycled water, you would need an entire new network of purple pipe. So when you hear this concept of purple pipe, that's a third infrastructure. You have a potable line, you have a sewer line, and you have a purple pipe. To get around that, you would have to implement in a system that allows what's called direct potable reuse. And then you can take the water directly from the wastewater treatment facility and put it back into the potable system. And that would require much less modification of the infrastructure. While groundwater injection is fantastic, there are legal limits to it. So the groundwater basins in Southern California are divided up, they're adjudicated. And what that means is that certain agencies can only put so much water down because that's all they get credit for, and they can only take so much up. So there's actually legal limits to how much water we can recycle at this point in time. If you get an opportunity, go tour the Edward C. Little water recycling facility owned by West Basin. It's fantastic. It's one of the most state-of-the-art water recycling facilities in the world. It goes through reverse osmosis twice, so this water is very, very clean. But they actually don't operate at capacity just because they're not allowed to pump down as much water as they could because they wouldn't get credit for it. So this conversation is bounded by policy limits. I hope that, in 20 years I look back and I think, wow, it was really crazy that we flushed potable water down toilets. But right now there's actually legal requirements in most cities in the United States that you can't use anything but potable water in the toilets. So, there's technical solutions, but there's also a lot of policy issues that have to be dealt with. And in terms of the yuck factor, we all drink recycled wastewater anyway. We're all drinking Colorado River. That's been recycled and reused and recycled and reused, 50 times before it gets down to us. So we're already doing it. We just don't internalize it.
Well, another question about behavior from our audience is that there's a perception that a lot of folks still aren't getting it, that people in neighborhoods are seeing their neighbors, using garden hoses as brooms, or they're watering, willy-nilly at all hours of the day and night, and they're not necessarily following the watering restrictions. How do we change that kind of wasteful behavior? How do we clamp down on that?
Well, I'll take that on. I mean, we in LA we've got water cops, and they I don't know if any of you saw Jimmy Fallon riding around with one of our water cops, but we do have people who go out and we patrol and make sure that if you report in a water waste, let's say you see somebody who's just wasting water and you report it, you can report it to us at waterwaste@ladwp.com or at 1-800-DIAL-DWP, or we have a phone app. It's My LA 311. It's a phone app. You can report water waste anywhere in the city, and one of our water cops will come out, and we call them our water response unit, will come out and look at that water waste. And what we do in the city is we're nice. First we try to educate our customer and explain to them, and most people will respond to just an explanation. If they don't, then we'll send them kind of a nastygram, frankly. It's a letter that says, hey, you need to comply with the ordinance. If you don't, there's going to be financial penalties. And then for a residential customer, if they still don't respond, they'll get a $100 fine, then it's a $200 fine, then it's a $300 fine, and then we can put a restrictor on their service. But here's a statistic. In this calendar year, we've had 14,000 reports of water waste in the city of LA. And we've gone through the process I just talked to you about, and guess how many people have actually ended up with monetary fines out of 14,000 who were violators? 6. Oh, it's a little higher than 6, but it's 75. That's a pretty good response. So the reality is that most people are not scofflaws. Once you explain to them what the ordinance is and how they can comply with it, they do it. So really that's how I think that you can answer this question, is just educate the public, have a good interaction with your customers, and 99.9% of the time they'll respond.
I think we need higher prices.
Yeah.
I think water should be free for a certain amount of water use so that everybody has the water that they need. But after that, you need a higher price. And it's illegal right now to charge more than what it costs to deliver. But until you get over that, you don't fix it. I don't think it should be possible to irrigate 30 acres in Los Angeles. We just don't have the water to do so. So I don't know that we can address the problem without a price. And it has to be high. It has to be free, and then it has to be high.
Yeah, it's challenging for people who can't afford it, but it's, yeah.
That's why it's free.
Right, right.
Speaking of innovations, I mean, there are mechanisms by which, and David was talking about one earlier of this idea of tiered pricing, but using pricing mechanisms and innovations are a way of getting at that, where you can maintain low prices for low-income people and really high prices for others. The problem right now is that we have barriers in our Constitution that I don't think were intended to limit or inhibit the ability of to impose these kinds of innovative pricing structures. But that's in fact what's happened, and we are the only jurisdiction that I'm aware of in the United States and really in the world that has inhibited itself from being able to use innovative conservation and low-income pricing structures in order to incent better behavior. And we've got to actually change that. We're going to have to amend the Constitution to fix that if we actually have any hope of really aggressively using a price as a signal,
and I know
in the urban environment.
And the governor basically echoed that frustration a couple of weeks ago, signing a water-related bill. Are there any petitions going around to get a ballot initiative on the 2016 ballot to reform? I think, what was it, Prop 213?
218.
218, right.
There is talk of such things.
Speaking of talk of such things, another question from one of our audience members. There's been a lot of talk, actually, whether it's William Shatner or whomever, about building pipelines to places that have more water, whether it's Washington State, although Washington State doesn't really have that much water these days. Folks point to the record snowfall in Boston and say, boy, if there was only some way we could just somehow pipe that water to California, we would solve our problems. I mean, it sounds like a really simple solution on paper, but I imagine in reality, Kelly, you're our resident civil engineer. Could we do it? Could we build a pipeline to the Great Lakes and basically suck that water?
No. So you could. Obviously, it's technically viable. But, you know, the one thing about water that we just talked about, and you all think I'm a villain because I want to raise water prices, it's too expensive. We are willing to pay for oil, so we move oil around the world because it's a high-value commodity, so we can pay for it. We're not willing to pay that much for water. It's not economical to move water hundreds and hundreds of miles. We've done it in California, but that infrastructure was built at a different time. We can't even maintain the system that we have now. So we have pipes bursting all over the city. That costs money to fix those. So why would we go and maintain more infrastructure? Some things make sense to move long distances, and those are things that have high value. Electrons we can move very quickly. I've proposed the idea of using the electric power grid as a virtual water pipeline, because you use a lot of water for cooling power plants, and that is demand that you can shift around. But in terms of actually moving the physical water resource itself, I don't think we could do it. We should do it through embedded trade or embedded products. But the physical water is too heavy. If you carry a gallon of water across this room 3 times, you're going to be tired, and that energy comes with a cost, both economically and environmentally. So I get asked this question all the time, but I just, and even once you get over the cost, you have the environmental impacts. It's going to get blocked.
I would completely agree with that, because we talked about that earlier, and that's why I think it's critical to try to capture the water here. And there are ways to do it. And I think that's really what the future is in terms of technology, I think. Finding to develop, pursue ideas that will address that issue. The piping the water is not the solution.
So what are some of the, and this has come up a couple of times in this conversation, that there are other approaches out there that might be easier, cheaper, more bang for your buck, that may not have the same, energy associated with it as desalination does. So basically low-hanging fruit where we could really, with the right technology, we could really maximize the water from it. What are some of those pieces of low-hanging fruit?
Trading between agriculture and urban sector in flexible ways that still maintain the agricultural sector, but and I realize that's less a technology and more of a sort of a legal construct, but I think that's the easiest and quickest and most obvious place to look beyond efficiency and recycling and stormwater that we've talked about.
A viable water market, basically.
A viable water market, yeah. A more robust and viable water market.
So, Lorcan, I'm going to turn this into a lightning round. So each of you get a chance to what's your favorite low-hanging fruit that you want to see turned into?
There is, again, as an architect, I'm in the mix with being approached to design projects, and we take the position as what are their aspirations of our clients. And they'll say we want to maximize our profit. If it's a developer in cities, developers do build cities. So I'm convinced there's a great asset there to be able to look at all the structures we're building as performative structures and really tackle it within the city, not piping water from elsewhere. And I think this is intriguing because formally it's quite interesting, materially it's quite interesting. If you start to rethink the materiality of walls and roofs and sidewalks and streets. So the city transforms itself, but in a very unique, interesting way where it's performing something. And I think that's something that's really provocative. So
what about the cost? In other words, to retrofit.
You're already building structures. You're always providing a roof is a roof, but there's ways you can design those roofs to be able to redirect it to a cistern or redirect it to a system that will filtering it. There could be a pump system that's tied into a structure. So you're pumping the water up from and through a filtering system, and then you can then redistribute and replace it in the water table. There's ways you can do it, but you use the structures you're building to do it, which means it's a hybrid program. It's possibly capturing water, cisterns, filtering systems. All that can be tied into how you build, whether it's houses, housing, or commercial buildings. These things are there. They're structures, you're doing it, and I think the incentive for these people who want to build will do it. But it has to challenge the public-private, the privatized quality of the city. It's very difficult to do it because when you have your land, you have a right to develop it the way you want. But how do you get them to recognize the importance of that? I was on a planning commission very recently where there was a whole issue of the drought. And it says, we can't build anymore. Think of the more people coming to the city. There's going to be there's more people. We don't have the water. We cannot build. So I believe that there's a way of taking two difficult issues, which is we are still building. People are coming here. But use that as a way of a resource to be able to tackle this other issue within the city.
Got it. So Kelly, just quickly, so what technology is going to give us the biggest bang for the buck?
I think recycled water. For every gallon of water that comes into the city, if 40% goes back down the drain, you've already captured it, you've already treated it, it's almost clean. So why send it out to the ocean? It's 40% of our supply. So I think that's the big opportunity for me.
Nick?
I would agree with that, but on the ag side, drip irrigation is obvious. The way we irrigate our crops right now, and there's very little incentive, and you went into the complexities around the policy and the senior rights and the junior rights. That's very complex environment, but technologically it doesn't make sense for us to be watering with our standard irrigation system when we can deliver water directly to the crop's roots.
David?
Well, this might sound a little simplistic, but the cheapest, lowest hanging fruit is always going to be the water you're not using. So conservation is really where it's at. I mean, the city of LA uses the same amount of water it used 35 years ago, and we've got 1.1 million more people living in the city of LA. The way we did it is through conservation. So the question becomes, okay, well, where do you go if you want to go to the next level of low-hanging fruit on conservation? Because indoor conservation, in some areas of the city of LA, it's saturated. I mean, there aren't a lot more that we can do. A lot of the toilets have been retrofitted in the city of LA. We've transformed the market on indoor plumbing fixtures. You can't go to Home Depot and buy high-flow fixtures of any kind anymore. So where is it? Well, again, it's going to sound like a simple answer, but it's outdoor landscaping. The culture in Southern California is a lawn culture. It's a very high water intensity culture, outdoor landscaping. So what we have to do is we have to change the culture of Southern California to a culture more like what they have in Las Vegas, more like they have in Arizona. You go to those parts of the world, and it's not an ugly outdoor landscape, but it's not, you know, the lush, you know, there's no restriction on water type landscapes we have here in Southern California. So we in the city of LA are still focused on outdoor landscape. We see that as the next level of lowest hanging fruit for us to achieve the kind of water resource bang for our buck that we can find.
Great. Well, we've got time for one last question here. We'll take it from David from Los Angeles, who's a member of our audience. And David wants to know what sort of innovative responses to drought have there been in other countries that also experience drought? What can we learn from places like Australia or Israel or the Middle East, other places that are sort of plagued by recurring drought like we are?
Well, I've been fortunate to go to Australia a few times now. Went with actually a delegation from Los Angeles of water agencies and politicians and others. And I think that the thing that I learned from, I learned a couple of things from what they did. One is that they really transformed their landscapes and also really transformed sort of what they were doing in their own homes. So you do see, everybody talks about their tanks. I can't do the accent very well, but they all got a tank, and they talk about their tank, and it's their cisterns, and every household has one, and they capture the water on site. So they're doing a lot in the home. Their water use per capita is considerably lower than even what we have here in Los Angeles, which is the lowest per capita rate in the United States right now, or at least for a major city. I think that their innovations, one cautionary thing that they've done is they built a lot of desal. And other than in Perth, which is on the west side of the country, they don't run any of those desal plants. They built them, and then the drought broke, and they didn't turn them on. The reason? It's expensive to turn them on. It's expensive to run them. And they found that a lot of other ways in which to deliver that water is a lot cheaper. Now, they have it as a security blanket, but it's a cautionary tale. They're still paying for it every single day, even if it's not running. So I'd say, you know, there's some really good things to look at with Australia, and maybe one to be a little bit careful about.
I think it's a very good point, the desalination. We talked about it, and I was aware of it too, that there's two different scenarios. One is the big move, and yet they're climate changed. So ideally, if LA was to do that, and what if, God forbid, we went through a very kind of volatile climate where there is a tremendous amount of water, if we were to build those things, and the cost of it would be prohibitive. So that's something we could learn from Australia, but also interesting that it was more of a bottom-up strategy, as you say, where each other house was doing it. It was manageable, and each person took accountability. And I think that's something really intriguing. When you deal with these larger infrastructural, there is an enormous cost issues. And I think there are ways of tackling that.
One of my favorite countries to look at for an example is Singapore. So Singapore recycles the majority of their water, and they do it because they're concerned about water security. So they've taken a lot of pretty aggressive moves in their water system to make sure that they have water security. They've gone as far as to stop agricultural production because they've decided they just don't have the water to do so. So they kind of traded food security for water security. So they really understand the value of water there, and they recycle almost every drop that hits the surface, is used, it's used and used again and used again and used again.
Do they do direct potable
they're starting
reuse?
to. Yeah, they haven't historically, but they're starting to.
Nick?
And just to riff off that, one of the other things they're doing with food is using more intensive vertical farming approaches, which uses much less water than regular crops. One technology coming out of Chile, which is of interest and being piloted in several countries right now, is in the realm of water purification, but using a low energy point for that by putting water in its fourth state, plasma. And this is a researcher from named Alfredo Zolesi from Chile. Puts water in its fourth state.
How do you do that? How do you put
ionizes
water in plasma? Go ahead, I'm sorry.
I'm not exactly sure how he does it, but he ionizes it in its fourth state, which purifies it at a much lower energy point than alternative approaches. You might have heard of Dean Kamen's slingshot. Have you heard of that? Basically put any kind of liquid on one end, no matter how impure it is, and on the other end you get consumable quality water, distilled water. But the limitation on that is the energy. And this particular approach uses a much lower energy.
The plasma approach?
Yes.
Huh.
And it's being piloted in many countries right now. Not ready for commercial scale, but it's on the cutting edge of research.
Excellent. Well, I think that concludes our panel discussion this evening. I want to thank you all. I want to thank our panelists, first of all. Let's give a round of applause to our panelists. And I want to thank you all for coming out and joining us this evening. Thank you so much.